Hello and welcome to the second part of inverse matrices. In this part, we're going to be doing some examples. We're only going to be doing three since they're not hard to do. It's just quite a bit of work depending on the size of your matrix. So we're going to go ahead and start with the first two, and it's telling us to find the inverse of the matrix 3, 5, 2, 3 and 2, 4, 1, 8. So for the first one, 3, 2, 5, 3, to find the inverse of any 2 by 2 matrix, it's really simple in how you do it. So in general, the inverse of a matrix A, B, C, and D is equal to 1 over the determinant, which is AD minus BC, and you'll learn more on that when we discuss about determinants. But for now, this is how you find the inverse of a 2 by 2 matrix. So it'll be 1 over the determinant times the matrix D, negative B, negative C, and A. So what we did is we just switched A and D and then multiplied B and C by -1. So for the first matrix, our inverse is going to equal to 1 over 3 times 3, which is 9, minus 5 times 2, which is 10, multiplied by A and D switch, but since they're both 3's, they'll pretty much look the same, and then -2, and then -5. And so what we end up getting is 9 minus 10 is -1. So this would be -1 multiplied by 3, -2, -5, 3, which is equal to -3, 2, 5, -3. And so yeah, that's the inverse of the first one. For the second one, again, we're just going to repeat the same process. And so the second one, I'm just going to use a different color, red. The inverse of 2, 1, 4, 8 is equal to its determinant, or 1 over its determinant, which is 16 minus 1 times 4 is 4. And multiplied, we switch A and D, which would be now 8 and 2. And then we convert the other ones into negatives. And so this is just equal to 1 over 12 multiplied by 8, -1. That's a terrible 8. -4, 2. And that is just equal to 8 over 12 is 2/3. -4 over 12 is 1/3. Don't forget the negative. Then -1/12. And then lastly, 1/6. And that is our answer for the second matrix. So moving on to another example, which in this case, this one is what you'll probably end up doing in most of your works, because the examples that we worked before, this method only applies to 2 by 2 matrices. So anything greater than 2, which is 3 and above, you have to use this method where we put this in augmented matrix and then we do extreme row reduced echelon form. So yeah, let's get started with this one. So the second example, we're gonna let C equal to 2, 1, 0, 4, 0, 1, -5, -4, and 1. And we have to find its inverse, which is denoted as C to -1. Remember, that's another way to write inverse of a matrix. And so we have to put this in an augmented matrix. And if you remember from the video, the left side would be the original matrix, and then the right side would be its identity. And so what we have to do now is move the identity to the left side, and then the right side would be its inverse. So I'm going to go ahead and start doing that. So we can start off by switching the first row and second row, and then switching that new second row to the third row. So row 1 and row 2 switch, and then the new row 2 and row 3 switch. And so what ends up happening is that we'll have 1 0 -4 0 1 1 2 4 -5. And then whatever we did on the left side, we have to do on the right side. And so this would be 0 1 0 0 0 1, and then 1 0 0. And the reason why I did this is because on the left side, we now have a leading one here and another leading one there. So all we have to do is just eliminate the 2 and 4, and then turn this last number, the -5 in the third row, to a 1, and we'll be done with that. But it's not as straightforward, as we still have to do a little bit of algebra. This is linear algebra, of course. And so what we can do now is we can have a third row and have it subtract twice the second, or not the second, the first row. And so that will give us a new third row. And so we'll have 1 0 -4 0 1 1. So the first two stay the same. The third one, so we have 2 minus 2, which would be 0. Then 4 minus 0 is just 4. And then -5 minus 2 times -4. So 2 times -4 is, or -2 times -4 is just 8. So we have 8 minus 5, which is just 3. And then again, whatever we do on the left side, we must do on the right side. So the first two stay the same, since they're the ones remain unchanged. The last one, well, the last one is just 1 minus 0. So that stays the same. On the farthest, or the third column of the right side, it would just be, again, the same because it's a 0. And then the left side would be -2. And so we're just going to go ahead and now get rid of the 4 on the third row. And to do that, we're just going to let R3 and then subtract it by 4 times R1, and that will give us our new R3. And so again, the first two rows remain untouched. So I'm just gonna go ahead and rewrite all of them, both on the left and right side. And so for the left side, we will have 0 minus 0, which is 0, good for us. And then we have 4 minus 4, which is 0. Then lastly, we have 3 minus 4, which would just be -1. Assume I did my math right. I think so. And so now this would be 1 minus 0, just say 0, negative 2 minus 0, again, stays the same, then 0 minus 4, that'll be negative 4. And lucky for us, this last row became a leading one. All you really have to do is multiply by negative 1. And so what we're going to do now, before we do that, we're just going to get rid of this 1 in this second row. And then to do that, we're just going to let the second row and then just add it to the third one, which just give us a new second row. And then what we're going to do is multiply the second or the third row by negative 1, and we just get our new third row. And so what ends up happening is the top one remains unchanged, so 0, 1, 0. And then the second row, well, we just add the bottom row before it was multiplied by negative 1, so that would be 0, 1, 0. And then we're adding, so it'll be 1, negative 2, and then 1 minus 4 is negative 3. And then we make the third row, it's negative, so it'll be 1, then it'll be negative 1, 2, 4. And yeah, all we have left is this 4, and we can, or not 4, apologize, it's negative 4. And all we have to do is just multiply it by the third row that's multiplied by 4. We're gonna add the first row by 4 times the third row, and that'll give us a new row 1. And so what ends up happening is, so now this time this time the bottom 2 rows stay the same, so we're just going to go ahead and copy those. And now we're just going to add the first row with the third row that's multiplied by 4. So, well, 1 plus 0 is just 1. And then same goes with the other one. And then this would now be 0, since it'll be negative 4 times 4, or negative 4 plus 4. And so we're now going to have negative 1 times 4, which is negative 4, and we're just adding that to 0. So this will now be negative 4. And then we'll have 2 times 4, that'll be 8, plus 1 would be 9. And then 4 times 4, 16. We're adding 0, so that is our final answer. And so, as I mentioned before, what we have here is on the left side, we have our identity matrix. And so the right side will now be the inverse. And so the right side would be our answer. So that means the inverse of C would equal to, or will be equal to negative 4, 1, negative 1, 9, negative 2, 2, 16, negative 3, 4. And that is our answer. And like I mentioned before, this is the process that you have to go with any matrix that is dimension 3 or higher. For a 2x2, you could just simply use this formula where you switch your first element and your last element, which is the bottom right. You switch those two, and then you multiply the other two by negative 1, and then you multiply the entire matrix by 1 over the determinant. I don't really know where they got this formula, or actually there is a way to deduce this formula. I'll probably just do that in a separate short video. I guess it would just be in the extras. but you don't really need to derive it. All you need to know is that this is how you find an inverse 2x2 matrix. And yeah, that's pretty much it. And so our next video would be focusing on determinants. So for now, I'll see you in the next video.